Our lesson today is nuclear reactions. A nuclear reaction is a reaction that involves the productivity of nuclear energy. During nuclear reaction, the mass of the product is less than the mass of the reactant. And the loss in mass can be calculated using Einstein's energy equation, which states that delta E is equal to delta n c squared. Delta E here is nuclear energy released. Delta n here is known as mass defect, and c here is speed of light. C squared is square of speed of light. And mass defect is the mass of the element lost when a given radioactive material is split into two parts. There are two types of nuclear reaction. Types of nuclear reaction. The first type is called nuclear fusion. Nuclear fusion. The second type is called nuclear fission. Nuclear fission. The difference between them is that in a nuclear fusion is a nuclear reaction that involves the coming together of two lighter nuclei at high temperature to form a heavier nucleus with the release of a large amount of energy. For example, if you have this nucleus T2, 1 reacting with D2, 1 to form another nucleus He42, helium nucleus plus theta. So here, these are two different lighter nuclei. They react and form a heavier one. You see the mass here is higher than the mass of any of them. And this theta here is the nuclear energy released during this reaction. The second type, which is nuclear fission, is a nuclear reaction that involves the breaking down of a heavier nucleus to two lighter nuclei with the release of energy. For example, if you have uranium 235 with atomic number 92, if this uranium nucleus is struck with either proton or neutron or electron, that is plus neutron 1 here, it will form uranium 23692. And because neutron has no charge, on penetrating this nucleus to form this other nucleus, it will create instability. That instability will lead to breakage of this uranium nucleus to form two other different nuclei, namely barium 141 and 56, and krypton 92 and 36 plus theta. So here is a nuclear fission, because this heavier nucleus is broken into two different nuclei. This is fission, nuclear fission. Now, if any of these nuclei captures another neutron again, it can lead to a chain reaction. Chain reactions are a series of nuclear fission, each initiated by neutron release from a preceding fission. Nuclear fission is what is used in the operation of atomic bomb. So let's look at atomic bomb. Atomic bomb. Two essential components of an atomic bomb are uranium and neutron. Essential parts are uranium and neutron. Now, atomic bomb consists of two or more fissile materials. Each of these fissile materials is less than a critical mass. Critical mass is minimum amount of material that is capable of sustaining a chain reaction. So these two subcritical masses are brought together. When brought together, they form what is called supercritical assembly, so that when they are connected together, it leads to explosion. That explosion can be so devastating, and so it is what nuclear fission can be used. It's essentially used here in making atomic bomb.